So, in this talk, I will talk about the hidden cost of dependencies, the questions you should be asking, the tools, a couple of tools that will help you find answers, and hopefully I will trigger some ideas and plant some seeds for how we can tackle it. So, who am I? Well, my name is Mattias Karlsson. I'm a partner senior architect at a consulting company in Gothenburg called WCOM. I'm also a Microsoft Azure MVP, so my head is in the cloud. I'm also a Microsoft Developer Technologies MVP, so I like the tools. And I'm also on the .NET Foundation Board of Directors. And I'm, well, very interested in open source. Been doing open source for 20 plus years. And most famous there is probably behind the K project. And also I'm a husband of one and father of two. So last but not least. So we're going to talk about dependencies, mostly about third-party dependencies, because those we can't trust. And what kind of dependencies do we have? Well, we have projects, but they're usually our internals. We have source dependencies we can fetch from NuGet or some other, like a submodule or something. We have different developer assets that we can join for tools or source analyzers or things like that. But most common we have are assemblies, which we fetch from NuGet.org. And also now, since a couple of years back, we have tools that came with the .NET CLI. So the short agenda for today will be, we will talk how we can investigate what lies beneath, because things have become more hidden than they used to be. We'll also see how we can act on our local machine to keep things up to date and things like that. And we'll also see how we can report. And here were I'm a manager that writes code, the most dangerous kind of people in the team, which means I have to do a lot of reports. And to do reports, I don't like to do them manually, so I will show some tools to do those kind of things. So let's start with investigate. So if we see a standard .NET solution today, it usually looks something like this. We have a solution file, we have some kind of .NET assembly project, we may have a console app or a Windows application or web or something like that. And often we have a NuGet config, we have a global JSON. And these files essentially are often forgotten. The global JSON defines which version of the .NET SDK you're using. So that will be important when we show some other things for a line, why that's important. And we have some of the most important of our project files where it binds together our code. So this is a very, like now with the new .NET SDK project format, or new, it came a couple of years ago, it's very dense. We see, looks simple, we don't have many dependencies here. We have what kind of project it is. It can be, if it's a Maui project, it's a different SDK. If it's a console application or assembly, it's this kind of SDK. We have what kind of target framework we're targeting. So in this case, we are targeting .NET 7. And we have our dependencies, which are package references, which we fetch from the NuGet.org or our private feed. So it looks simple. From the surface, this project doesn't have many dependencies. So if we look at our sample project, we can see the starting point is that, well, we have just these two dependencies. So we have a NuGet package core asset bicep decompiler and a cake breach dependency action. What are aren't important. What's interesting is when we do a .NET restore. And .NET restore is when we fetch the dependencies from our feeds, and it doesn't just do that. So let's do restore. So now our project is restored, and look, how does our dependencies look now? And now we run away and see that, well, it wasn't just two dependencies. It's all these dependencies that lie beneath. So how come? So if we look after restore, we will get a new folder called obj, the obj folder. And most importantly, we will actually have a project asset JSON. And this is the total dependency graph after restore of your application. So we'll have all your runtime dependencies. It will have your NuGet packages. Also, if you have project dependencies and assembly dependencies. So you can see now when we did the restore, we'll have this nice file which someone barfed in, which is essentially a declaration of everything we depend on in our project. So usually if you've been from the .NET old days, we used to have a package config and a CS project that has everything defined. Now it's hidden here and it's called like transient dependencies. Dependencies that have dependencies. It's actually me. And we also have a NuGet cache, which are essentially the hashes of things and where they fetch the packages and things like that. We also have, aren't really important, but we have things like those are properties and things that are important. It can be like you should have implicit namespacing or things like that can be imported from others. Also, MS build targets can be fetched from NuGet packages. So let's do a build, because then it gets even more interesting. So if build, we'll also get our bin folder, which if we have a debug or was release name, and we also get the output folder, and to also have a dependency JSON. It's very common similar to the project JSON, but it's also contains runtime information and things like that because it's targeted to that. So you will have even more information. And so we have these dependencies. We will also have things like our DL. We'll also have debug symbols if we compile with that. So how can we keep these things in check, or how can we keep ourselves informed, or how can we like see beneath this as a developer when we look at things? So let's look at investigation. So there are the tools. I will show you a series of tools. All are free and open source, so you can try them out for yourself. It won't cost the team. It only costs you the time you take to invest in them. So one tool I will display, and the author is actually here of the tool, is called Depends. And it will, so .NET tools are installed from NuGet. So you will use the .NET tool install. You can also pass the -g argument here and we install it globally, so it will be available for all projects. You can also specify path if you want to install it on a path. So now the tool is installed from NuGet and it's available. If we just want to verify it's installed, we see that we have the tool installed. So let's see if we start it and let's look at it. So this is like the beautiful UI with the text box, but one interesting thing here is that you can actually visualize all your dependencies. So if you go to, what I think is reverse, so if you go all the way up to the project, we can actually see down, this is the main project. It has these runtime dependencies and these package dependencies, and we can easily get a code smell if something is heavy in dependencies without needing to look into all things. So we can go down and see that this package has new.json of JSON. We can also see all the packages that reverse depends from new.json, where you can see versions. And these are, you can see there's ranges, and NuGet has support range. So you can specify either a specific version when you do a dependency. You can also specify the most common is this one or greater. And that's important, like if you see something like, you can always restore with a lock file, then it will be exact. But the problem is with transit dependencies that you don't know sometimes what versions you will get. So this is a great tool just to be able to see and to just visualize how much technical depth sometimes almost is in this project. So visualize dependencies, you do a .NET tool install, .depends, and then you can do .NET depends. And it's available on NuGet. And it's really nice. Another interesting part, I talked about transient dependencies. And transient dependencies are dependencies that you get because another package is dependent on, has dependencies. So a good tool there is, I would say, Snitch. It will identify unnecessary transient dependencies. So let's take a look at that. So if I exit this one. So .NET tool install Snitch. And then we see that it is installed and see the arguments. It takes a project or a solution as an argument. So let's run that. It will analyze and it will see that our console application, in this case in the solution, is referencing this project, which already has dependencies. So if we look in code, we can see that our console application has a dependency on the .NET Core, which already references this, which means we now have to, for good or bad, have to version this in two places. So we can actually have a code still work and just remove these because they are implicit, because I don't use it. The tool identified, I don't need them here. So if we rerun, everything looks good, which is one way like to reduce the number of files you need to version, but also you have to know what you're doing because you also hide things. So Snitch, .NET tool install Snitch. The command is .NET Snitch, and it's available on NuGet. Free, just use it. So how can we act on things? Like how can we know that our things are up to date, that we don't have, well, it's tedious to go through, like I don't want to go surf out to NuGet.org and check all my packages and all my transient and everything. So there are tools to help with that. One tool is called PackCheck. So let's try that out. So install it, .NET tool PackCheck. And you'll see, so it's installed, it is. It takes either a CSProj file or a solution file as an argument. So let's run that. And here we can see that it has analyzed my solution and see that I have current version is older than the latest. So an easy way to see that I have gone through my whole solution, gone through all packages and see that are up to date. So we can just go through this, install, run, and then. There's a similar tool which is my preferred tool, just because I've found it. I used to use a tool called NewKeeper, which currently isn't supported anymore. So this replaced it with this tool. And if we look at it, it's very similar. You will install it. Once available, you will do .NET outdated. And it will also go through the solution, identify these for each project. These are the versions that needs to be updated. So let's update them. So we just do a -u, and it will actually go through all the solution update, and the previous tool can do the same. And this is where you can run your tests and but can see that you have found everything. You have removed duplicates with the previous tool. You have now identified, and everything is up to date. So outdated. Identifies and updates outdated dependencies. It's installed with .NET tool. You launch it with .NET outdated. You can pass the path to the solution project or path, and it will find files outdated. And it's available on NuGet for free. So now comes the fun part. Well, not everyone thinks fun, but how can we report this? Because one major thing, like if we learned something for incidents like log4j or something, is that when the manager comes to you or someone else read on the news that this dependency, it has a security vulnerability, and like they ask you, are we using it? And like, how would I know? I only have 2 dependencies in my. How would I know if my dependency of my dependency of my dependency of my dependency is using this file? That's why we need reporting. So let's go through a couple of tools. There's one called DPI, which is written by myself because I had the opportunity. I needed to do these kinds of things. It's also available on NuGet. So you do .NET tool install DPI. It's then .NET DPI, and you pass. It can either analyze or report. Analyze will just print out to the console. Report will report to Azure Long Analytics, so you can actually correlate between repositories and have one central repository of information. So let's see what it. And this was the tool I ran before to just visualize. So it can be a nice way to quickly visualize things. And also, if you're running on a build server, it will identify things like AppBayer or GitHub Actions or TeamCity or a couple of build systems. So we get those in the logs to. It will also identify the build number, and you can also pass build version and things like that to it. And it will have a unique session, so you can follow it. So that's. If we have time, I can show more the reporting part later. There's also a tool we can just blast through called SBOM. This SBOM tool comes from Microsoft, so it's actually what they use internally to report tools. You install it, and of course, by Microsoft the naming, it's called Microsoft.sbom.net tool. And one advantage is that it's not just .NET projects. It will also go through containers and node-ready npm packages and things like that. The only, I think, disadvantage is that it has no sensible defaults in my mind. So if you run an example here. Let's see. Oh, it didn't scroll down. Let's scroll down. It's a million knobs and switches. This is an enterprise tool. In my mind. Yeah. So it will things. And essentially, if we look at what it creates. So let's see the artifacts. You will get a JSON file with things like it should, and that's one bug they currently have. They don't fully support license on NuGet, but it will get all the versions of your assemblies in a nice assembly packed file. So if we look, let's see. So look at this, the SBOM file. Well, it's not a bomb, it's a list. And it's a software bill of materials. So essentially, it's the recipe for how your software is built for dependencies. So if someone asks a question, you can deliver this in a standard format. And there's 2 major standards there. There's Cyclone DX, which is from the OWASP project. So the Open Application Security Project. They usually put out things like security bulletins, and the top list is people probably know. And the other one is the one we create now. It's called SPDX, and that's from the Linux Foundation. It's also an ISO standard, so it's very common. So usually that's what the tools usually work with. So you can find everything you need to know if you want to read more on the cyclonedx.org. And there. So if we see the SBOM tool we just ran, it creates at SPX 2.2. The latest is 2.3, but it's 2.2 is the most common at the moment, I think. You install it with .NET Tool install, and you will get a file, and then you run it for that. But you need to get all the knobs and everything right. I think the other tools, and we'll go now, is a bit simpler. It's one called from OWASP, so they have a .NET tool called Cyclone DX. So let's take that for a spin. So install it, .NET Tool, install Cyclone DX. You can see that it's installed, but one nice thing I think is that it has fewer knobs. You just specify the project and that you want to report. And you will have a nice bomb.json in the Cyclone DX format. And here you will see things that it actually found out the licenses, so you will know what this project is MIT, what other kind of licenses are out there. So you can see, you also get kind of important things like the hashes of packages, which means if you haven't changed versions, the hashes of the package shouldn't change, which means you can assert things like if you report this and you haven't, it's like if someone, like one of the most, dangerous things are like if someone infects your supply chain. If someone injects an assembly while you're building your code, you don't know it. This way you can do, if you do this as a separate witness, you will have the hashes in one place of the dependencies. So, creates Cyclone S-bombs. It's a .NET Tool install, so you can use it both. And one big advantage with .NET Tools is that it will work just as fine in your CI pipeline as on your local machine. And I think that's really important because there's so many tools where you use a web service or something and need to upload something, but it's nice to be able to just, to add a line to your CI YAML to just execute this tool and add as an artifact. So you can have it just as a part of your build. And if you use something like GitHub Action or use templates in Azure DevOps, you can just have it in all your pipelines and have an artifact for your pipelines. And another tool we really like for software development is called Covenant. And it will be able to generate both Cyclone DX, SPX, HTML, SBOM, and its custom format. So it also has its own format. That's the default one. So if we look at that, install it. That will make a tool called .NET Covenant available. It has a couple of commands. The most common is generate, which will generate the SBOM. So let's run that. So now we have generated in the custom format, which is a JSON file which have all your dependencies. You have the hashes, the licenses, so everything you need. And this tool this is the custom format for this, but it can generate the Cyclone V or the SPX reports. It also has command to convert them. And one really nice thing is if you talk to managers, you can also convert these to an HTML, which you can attach to, like if you do Azure DevOps, you can attach them so it's available in your build results. So you get this nice HTML. So let's do. You know the developer, but it's nice to have a report which has like what license am I using. This has 101 packages that uses MIT, one that uses Apache 2. You have unknown licenses, which are some of the Microsoft licenses, because the runtime is licensed a bit differently, so you have to go to it. And you have things like the Azure Storage, SK, others. So this is a way to identify and get something to give to your manager, and you can see all, which is, I think, is a really nice addition. And you can see what dependencies they have on the service. So I think it's a good. I mean, the .NET Standard Library is part of what you get on the SDK, and that's why it's important if we go to and check this. Many forget this. You should have a global JSON, because all the implicit dependencies that you didn't see from runtime, the version of those is specified by this version. So if you have an old version here, you might have old unpatched. And that's a new thing Microsoft, that they will release essentially a new .NET version every month now. It's a minor release, but I will release it. And things like this are like you can, if you have the preview builds on your machine installed, it might go up automatically. So you can specify, I don't want any preview builds for my production loads when I build on CI. And if you use things like in Azure DevOps or in GitHub Actions, there are a .NET install task. Then it will pick the global JSON version so your builds are reproducible and use the same SDK version each time. You can use things like to make it easy for developers. You can say that I will allow to roll forward on the developer machine so they can actually have a newer version to build so they won't break every time. But on CI, it was always use the version specified here. And that can be feature or essentially the last 3 digits. You can have major or minor roll forward too, if you're, depending on how daring you are. So I think Covenant is a really nice tool. It's open source and it's made by Patrick Svensson. So it's one of like the Spectre console usually then was. Well, we like tools in DevOps because we don't want to do things manually if we can do it automatically. So it's really nice. It will generate both those. It's easy to install and it's available on NuGet. So we're good on time. So we can show the importance. Let's go over to here. So I said one thing, and you can do a lot of that. You can do this with PowerShell or whatever you want. But one thing which is nice if you have a central repository for these is that you can do queries against without having like going to like the could be that the code is protected. So it's nice to like export it to somewhere else to have something where you can do queries. Log Analytics has Azure as a service which has a query language called KQL, which is really powerful and really fast to go over vast amounts of data. So, example in this query, I will get all build reports the last 30 days. I will find the last report, and I will join on that, and I will get the packages for a GitHub project called Bri. So, we don't have select. Let's go. So, and it will output nice graph like what are the packages, what are the versions, which CI did it build on, and it even does .NET tools. So you will see the versions of the .NET tools. Just zoom in a bit. So, not too much. And you can even, there's no good column there. Let's go to the null query. Let's see what are the top 10 packages for all. Then you can go things like show your manager a nice chart, because that's when you like what the best packages. You can we want the pie chart. So then we can see of all repositories over all the builds in our organization, what are the packages that we are using. You can get the versions. So if I have an incident, you can do, and that's what's nice. Like if you have an artifact with your SPX or something, or your report log analytics or some other like big data analytics tool, this means that you can, when you get the question, you can get it this quickly, the answer, like, do I have these dependencies? Have I had these dependencies? Because it can also be a previous version that the customer has running. It's so easy for developers to look at, oh, this is the current version. We're not affected. Well, it's not a feature until it's deployed. That's the classic. And we can do also things like filter for total, for not the latest, but you can do a lot of things with this. It's a really powerful, and it goes through hundreds of thousands of records really quickly. So I've run this every day for like 20 projects, and it just breezes through. So that's really powerful KQL. And this is the same if you use Azure Monitor or Log Analytics or App Insights. It's the Log Analytics workspace, but you can actually do custom logs. And that tool is open source. So like if you don't want to do your own custom logging, you can just steal away. So that's, I think, a really nice addition for how you can keep track on. Like if you can not just like, it shouldn't just be a build artifact. You need to be able to do something with it. Either do like with Covenant, where you can do a report of it, so something you can show in your, something usable. But also, it's good if you're able to query it. And if you have a JSON file, most of the big data systems you can just dump in JSON files recurrently in your big. And all, like I said before, the big advantage with tools is that you can use them both locally and in your pipeline. You can chain them together. You can do things. And also important to see that what you see at first might not be what lies beneath. There are things hidden. Here be dragons in a way. But also with like, if you, like I do help a lot of customers with audits, you might be asked like a third-party auditor like, I want an SPX log. Then it's good to know that there's tools that can do it in minutes, so you don't have to, how do I do this, how do I put this together? Or I need a Cyclone B because there's different auditors will request different logs. You can just, and that's what nice with a tool like Covenant is that it can generate all three, which is kind of nice in my sense. So that's all I had. So questions, anyone? Yeah. Well, if you look at tool like the .NET Outdated, it will treat, you should always beware if you're using preview versions. So then it will flag those red as potentially breaking. It will also flag major versions as potentially breaking. So you shouldn't just, there are scenarios where you shouldn't have your colleagues just to go .NET Outdated updated. Because there are some scenarios where Microsoft, especially Microsoft, doesn't follow the December rules. You can see like with Azure Functions, with the like the in-process isolate functions, which were the ones up to .NET 5, those are just work up to .NET 6. And if you want to go above .NET 6, for the new, then you have to do the isolated Azure Functions. Those won't work with .NET 7, like dependency injection assemblies. So if you just go update, then you will in for an Azure function that doesn't work. There are also some other things, like if you use more advanced UI stacks, it could be that you have some things that aren't compatible. But if you're just using a console application, usually it's compatible. But fortunately, hopefully you have some kind of automatic tests in place. So you can, and if you have a CI, then you have things like Renovate, which is a bot which you can run both on Azure Pipelines and GitHub Actions and others, which will go through and actually create pull requests. On GitHub Actions, you have Dependabot, which is also a tool you can enable to go through the dependencies for you and create pull requests. There is a pull request to get Dependabot to work on Azure Pipelines, but it's not merged yet. But I think Renovate is a really cool tool, which you can use. And it can also go against authenticated feeds and things like that. But the good thing about these tools I just shown, if you can build it locally, you can inspect it locally with this tool. That's any more questions? Yeah. Yeah. No, Outdated is mostly for local machine. So Renovate will work on its own. There used to be a tool that I mentioned that isn't supported, like it was Newkeeper, that could do both. But the developer got tired when .NET Outdated came, so like do this instead because they didn't think it was worth the work when something official comes. But that could do both. So that doesn't just work up to .NET 5, but that could do both. But Renovate is more advanced because it also go things like your node modules and your pip modules if you use Python and things like that. So it's supporting more formats. I think the lesson was like, it's important to actually know what you have in your stack. Because if you get the question, do I have this? You don't want to go down the rabbit hole at that point. You want to be able to give an answer quickly. Because when everything's down and your customers are calling, then you want to be able to say, yes, we have this dependency, we took it down because of this, we will have an action plan. But also things like if you have PCI compliance, if you have like something like e-commerce or something like that, you need to be able to deliver these files. And you maybe don't want to have them in a third-party service because of GDPR and things like that. Then it's good to have a tool it just works locally or in your protected build agent or something like that. Yeah. Any more questions? Yeah.
Are there any way to find good packages that not reference
Yeah, I know that if you have the ReSharper tools, they have things like that. Actually, they have a command line tool too. Yeah, well, they have a command line tool. I think that's free on, but there are tools for commercial tools for that. And I know Visual Studio has it too now in a way. But you have to manually remove things that are used, like namespace and things, before it can identify them. So you can essentially right-click deploy to remove them. But that's why so nice with transient dependencies is that if you only reference what you know you use, everything else is a transient dependency. So if a package no longer has a dependency, then you no longer will have that dependency automatically. And that's what was the problem with the old .NET project format. We had a package JSON where everything, all package IDs was specified. That means that you always had the config of that. Well, this has this version and this has this version. That's sorted. And if you really need a stable, like I must know exactly what's going on, when you do the .NET restore command, you can actually save a log file and commit that to your repository, then it will be used. But that will also, it can potentially be, then you really need to observe if a package gets unlisted or something. An advantage with something like the ranges when NuGet says this version or higher means like if NuGet flags a package as hidden because it has security vulnerabilities, then it will pick the next version automatically. Yep.
Is there any tool that allows us to bind a certain version of a library to a specific hash, so that if at some point another hash comes for the same version?
It will never, like, NuGet.org will never allow you to upload the same package with the same version. So the hash should never change. That said, things can happen. Like GitHub, not GitHub, Git recently changed how they do archiving. So they switched the formula for gzipping or the tar files, which means that all hashes for things that were downloaded for GitHub changed. They reverted that change because that was bad. But the whole idea about hashes is that they should never change. Then there should be a new version. The packages should be immutable because if they change, then you have been hacked.
Yeah, exactly.
In some way. Yeah, but that's why, like, what you should do is that if you have your SBOM or your manifest or something stored, you can always compare, like, if I didn't change a CSPROI and that changed, you can essentially, if you want, you could commit that to, and some tools are like, you can pass an argument to essentially like the snitch tool, so it will give a different result code if it has those. Then it will fail the build pipeline if you run those. And many tools can do that. That you can say, like, I want to fail the build if there are newer versions. So you can do that with tools because they will have an exit code that fails the build. More questions? I know I'm between you and beer. Oh, shit.
Does any of these reporting tools even calculate an SBOM for JavaScript?
Well, Cyclone, if you go into the OWASP Cyclone, they have tools for each programming language. So they have like in the main repository, they have a bunch of tools. Yeah. So then you will use, so they have a tool for .NET, which is the tool I shown. They have for Docker containers, they have for all sort of things. And the important part with Docker containers is that there you actually, in many scenarios, can push a new manifest for the same version because it's the same, many use the latest version. And that's essentially like you can use that manifest because essentially they're just layers on a container registry. And that's just a JSON file, which is the manifest of the layers. And that you can see that the hash have changed. And that's what those tools use. You essentially query your package registry. What are the layers of my container? And they have tools for a lot of languages. And SPX is a standard, so there's a lot of tools for different. And the SBOM tool from Microsoft will go through both node modules, pip modules, Docker containers also. But it's you don't fall into the pit of success because you will have to specify a lot of arguments to it. It's an enterprise tool. What I like about both the Cyclone tool and the Covenant tool is that you essentially just look here and have a good sensible defaults, and then you will, if you have something that doesn't match the sensible defaults, then you add that as an optional parameter to change the things. But I mean, yeah, and also the SBOM tool, all these are on GitHub and open source. You can Because there's one issue with Microsoft where they don't identify the licenses for NuGet packages. They do it for everything else. And the problem there is that they depend on another Microsoft tool, which another team manages, which currently don't work with NuGet. But I mean, you can also combine, because if you use a standard, then there are, like, you can take all these reports, like you can use different tools. Like this tool works best for X. As long as you can do a reporting standard, then it doesn't matter which tool you're using. Cool. Any more questions? I will be at the party, so you can always, if you want to talk DevOps, automation, things like that. Well, then thank you. Dev lead most places. The presentation is there and the code is also there. So you can go check us out.